In this video, we're going to learn how to take the skeletal structure of some alkane, haloalkane, or nitroalkane and convert it into its systematic name, or take a name and convert it into a skeletal structure. We'll be communicating with each other through both structures and names, so we need to have both of these skills. Now, there are many compounds that are naturally occurring and have been known for hundreds of years, such as the ones that are shown on this slide, and they have what's called a common name. However, with over 70 million known organic and inorganic compounds, we must have a systematic way of naming molecules. Otherwise, we would just have to memorize 70 million common names, and obviously that is not possible. So knowing some common names is good, but we need to have a systematic way for naming anything. Okay, we are going to start with alkanes. Now, alkanes don't technically have a functional group, as you know, but the rules for naming things are going to be based on functional groups. So since alkanes aren't technically one, they're going to have the simplest rules. So we're going to start there. So for example, alk means hydrocarbon, so it means the molecule contains carbon and hydrogen only, and then ane means there's single bonds only. So for example, you can imagine just a 1-carbon hydrocarbon. This is called methane. You could imagine a 6-carbon hydrocarbon with only single bonds. This would be called hexane. Okay, hexane is an example of a straight chain hydrocarbon. All of those carbons are in a line. So when you want to name any straight chain alkane, you're going to use a prefix that describes the number of carbons in the chain. So we had hexane before, 6 carbon atoms in the chain. The prefix is hex, okay? Let's go back to the beginning. When there's 1 carbon, the prefix is meth, 2 carbons F, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct or octa, 9 nona, and then 10 deca. Okay. All right. Now, for straight chain alkanes, super simple. You just use the prefix that has the right number of carbons, and you put ane at the end. You do need to memorize these prefixes. So, can we name this straight chain alkane? Of course we can. We need to count the carbons. There's 5 carbons, so 5 is pent. It's only carbons and hydrogens, all single bonds, so pentane, where ane again means alkane. Awesome, let's take it up a notch. So now we're going to look at a substituted alkane. So when we think about what a substituted alkane is, we're just going to take one of these hydrogen atoms. We'll take this one, and we'll replace it with some group. G just means group. So why don't you pause and see if you can draw a generic substituted octane. All right, oct would have 8 carbons, so let's draw an 8-carbon chain. Let's make sure we did that correctly. 1, 2, 3, 4, 5, 6, 7, 8. And then you just want to put a substituent anywhere. So maybe on carbon 4. Maybe you wanted to do it on carbon 1. Anywhere. Okay, so there's lots of possibilities here. Now we're going to start looking at substituted alkanes where we have a halogen as the substituent or a nitro group. So when the generic group is nitro, we'll have a nitroalkane. When G, the generic group, is a halogen, we'll have a haloalkane. So we have our halogens, our group 7A elements here. So some examples of substituted alkanes with nitro or halo groups are right here. All right, so we're going to try to name these. So the first thing that you want to do is identify the longest linear chain of carbons. So the longest linear chain of carbon atoms, this becomes the parent chain. So why don't you go ahead and do that for each of these molecules. All right, because these are all straight chain, it's relatively straightforward to find the longest linear chain. Okay, so there we go. The name of the substituent is going to give you sort of the prefix that you're going to put in front of the name. And then we're going to need to give the location. So let's just apply these rules to once. We'll look at this first example. So we had 5 carbons in the longest linear chain. So this is going to be a pentane. And then the nitro group, nitro, that's at carbon 3. And we need to give its address. So 3-nitropentane. I need to give its address because that distinguishes it from, say, 1-nitropentane. Now for this first example, there was only one way to number the chain. I numbered it from left to right, but if I had numbered it from right to left, I would get the same thing. I would get 3-nitropentane. Now that's not the case for the next molecule. For the next molecule, if I number from left to right, I would get a 3-bromo. But if I number from right to left, I'm going to get 1-bromo. We are going to number the chain to give the substituent the lowest number possible. So this chain will be numbered from right to left as drawn and be called 1-bromopropane. Finally, the last example, let's just be sure we have the lowest number here. Oh, nope, when I number from right to left, my substituent gets number 3, so that's what I'm going to do. And this would be 3-fluoro, 6 carbons, so hexane. Okay, so now you should pause and try to name these compounds using the rules that we've just applied. All right, we're going to identify the longest linear chain of carbons. So 1, 2, 3, 4. And I want to give the substituents the lowest number possible, so I do need to try the numbering from left to right and right to left. I can see that 2 is the lowest number possible for those substituents. Now those substituents are chloros, and there's 2 of them. So it's going to be dichloro, and I'm going to say 2,2-dichloro. There's 4 carbons, so that makes it a butane. So 2,2-dichlorobutane. So the di tells me that there's 2 chloros, and then I do have to give the address, the location of both of them, even though they're on the same carbon. All right, next example, if you haven't tried it, go ahead and pause and do that. All right, so this one is a little bit tricky. So we have 2 possibilities. So we have a bromo, we have a fluoro. So first of all, let's just deal with how we're going to put bromo and fluoro in the name. When you have multiple substituents, you do want to list them in alphabetical order. So this is going to be a bromo, fluoro, ethane. Okay? So when we have multiple substituents, you're going to list them in alphabetical order. Let's add that. And then now the question becomes, what number do you give each substituent? Because no matter which way we number the chain, we're going to have 1, 2, right? It's either 1 bromo, 2 fluoro, or 2 bromo, 1 fluoro. You want the lowest number first in this case, so you would do 1 bromo, 2 fluoro. I know, it's this rule can be a little bit confusing here. either way, you have a 1 and a 2 in the name. And so in that case, you want to just choose the lower number to be first. So there you go. All right, so this example that we just looked at with the 2,2-dichlorobutane, we had to add a prefix, the di, because the main chain had 2 or more of the same substituent. So you also need to memorize these prefixes, which help you to indicate that there's more than one of a given substituent. Okay? So carefully read these rules. Now let's see if we can provide the name for this compound. So pause and give it a try on your own. All right, we want a number from left to right and from right to left. And the reason that we're doing this is to be absolutely certain that we give the substituents the lowest numbers possible. So let's go ahead and see what those numbers are. Numbering from left to right, we would get 2, 2, 4, 7. Right? Because these 2 chlorines are on carbon 2. This one is on carbon 4, and this chloro substituent is on carbon 7. So 2, 2, 4, 7. In contrast, if we use numbering from right to left, the red numbers, we would get 2, 4, 7, 7. So we can clearly see that numbering from left to right, the purple numbers, those give us the overall lowest numbers for the substituents. So that is the numbering that we would do of the chain. And then this compound would be called 2,2,4,7. There's 4 chlorines, so that's tetra. So tetrachloro, that's how we name a chlorine substituent, a chlorine group. Octane, because it is an 8-carbon ring. So 8 carbons, oct, ane, because there's only single bonds. Excellent. Let's take it up a notch. We're going to look at branched alkanes. Branched alkanes occur when you have an alkyl group as a substituent. For example, this is an example of a straight-chained alkane. It's pretty simple to name because we can see that there are 5 carbons, 5 has a prefix of pent. There's only single bonds, so pentane. Now, in our second example, we can see that there are still 5 carbons in the parent chain. So we still have a pentane parent chain. But we have this 1 carbon substituent, this branch coming off of it. So to name a branch, we're going to use the same prefix as we were using before. And then instead of adding ane, we use a YL suffix, YL ending. So this means that it's a branch. So for example, if we have a 1 carbon branch, this will be a methyl group. A 2 carbon branch, that would be an ethyl group. A 3 carbon branch, propyl, and then so on and so forth. So the 4 carbons, 5 carbons, 6 carbons, etc. And again, this YL means it is a branch. It is attached to something. This squiggly mark here also means that is attached to something. And that something is a longer chain of carbons. Now, once we get up to 3 and 4 carbon branches, there's different ways that the carbons in those branches can actually be bonded to one another. So imagine for this propyl, we have carbon 1 is bonding, so the first carbon of that chain, that's bonding to the parent. But imagine you could also have carbon 2 doing the bonding. Okay? So this is still a 3 carbon branch, but it's a different arrangement of the carbons. So this is called an isopropyl group. You kind of need to memorize that. And we'll look at one more. So look at butyl. We have a straight chain of that 4 carbon substituent. But you can imagine that maybe you had an arrangement of the atoms like this, where it's still a 4 carbon substituent, but you have one of those carbons, this one, carbon 1, bonded to 3 methyl groups, and this is called a tertiary butyl is the full name. So tertiary butyl, which is often abbreviated T-butyl. Okay. It's worth pointing out what tertiary means. So tert is an abbreviation for tertiary. Tertiary means bonded to 3 other carbons. So look at carbon 1. It's bonded to 1, 2, 3 other carbons. So it's a tertiary carbon. And that carbon 1 is the one that's bonded to the parent chain. So we kind of care about it. It's a tertiary butyl. Let's practice naming some branched alkanes. We're going to apply the same rules that we did to the previous examples. So find the longest linear chain. Number it to give the substituents the lowest number possible. List the substituents in alphabetical order. And then followed by the parent chain. Excellent. So hopefully for the first example, you've identified that there is an 8-carbon longest linear chain. Now, the carbons in the longest linear chain may not be drawn out all in a nice line like this. So for example, we could have gone along the chain the way that we did to get the 8 carbons, but also we could have gone up here. This could have been carbon 7 and carbon 8 as well, because it also makes an 8-carbon chain. But in this case, it makes no difference. We're going to get the same name no matter which direction we numbered here. So now let's take the longest linear chain that we found and number from left to right and right to left. So from left to right, the purple numbers, we would get 2, 2, 6 as our substituents. For right to left, we would get 3, 7, 7. We can see the 2, 2, 6 is lower set of numbers. So what that means is that we're going to use the numbers in purple, numbering from left to right. So let's look at what we have here. We have 2 methyl groups on carbon 2. They're methyl because they're 1 carbon each. So this is going to be a 2,2 dimethyl, all right, because there's 2 methyl groups. And then here on carbon 6, that's a 2-carbon piece, so that's going to be 6-ethyl. So now how to string all of this together? Well, you want to do it in alphabetical order, and you are alphabetizing by the name of the substituent. So you're not alphabetizing by the D in di. It's by the M in methyl and the E in ethyl. So this would be 6-ethyl, 2,2-dimethyl, and then we list the parent chain, and that's octane because we have 8 carbons, and ane because there's only single bonds. Now for the second example, we could have this longest linear chain highlighted in yellow, or we could have gone down and done this, and either way we have 5 carbons. So we have 2 possibilities for the longest linear chain. Which one do we choose? Well, we're going to choose the one that has the most substituents on it. And that would be the pink one, because the pink one would have 2 substituents on it, whereas if we went with the yellow chain, we'd only have this 1 substituent. So it's going to be the pink longest linear chain. So see if you can name this before I do. Now we are going to want to number the chain this way, so 1, 2. If I numbered from the other way, I wouldn't get a substituent until 3, and so that's going to ultimately have higher numbers. So 1, 2, 3, 4, 5. We have a 1 carbon piece, so that's going to be methyl. And we have a 2 carbon piece, or 2 carbon substituent, that's going to be ethyl. Again, we're listing in alphabetical order, so this would be 3-ethyl, 2-methyl, 5-carbon chain, that makes it pentane. Moving right along, we will also encounter cyclic alkanes, and we'll encounter them both as the parent chains and as substituents. So if we're just looking at the cycloalkanes themselves, they're named probably just about as you would expect. So we have a 3-carbon cyclic alkane. Cyclo goes in front, that's because it's a ring. Prop, because it has 3 carbons. Ane, because it's all single bonds. Cyclobutane, cyclo for a ring, bute for 4 carbons. 5 carbons is cyclopentane, 6 is cyclohexane, 7 cycloheptane, and 8 cyclooctane. So we can have them as the main chain. We can also have them as substituents. So we can look down here at these cycloalkyl groups. So these would be as substituents. And it's the same naming. There's the number of carbons, so such as prop, cyclo because it's a ring, and then il because it's going to be attached to something else, to some other parent chain. So why don't you pause and try to name these cyclic alkanes? All right, let's take a look here. So we have a 6-carbon chain versus an 8-carbon ring. So because 8 carbons is more than 6 carbons, the ring is going to be the parent, or what I referred to as the main chain before. So this is going to be a cyclooctane. And then this is going to be our substituent. So that's going to be our substituent. You can see on carbon 1 of the substituent, there is a methyl group. So 6 carbons, that's going to be hexyl. And then on carbon 1 of that hexyl, there's a methyl group. So this is 1-methyl hexyl cyclooctane. And you do need to put this in parentheses, so put the name of the substituent in parentheses, because otherwise it's going to be a little bit confusing. Okay, so the 1-methyl refers to hexyl, so just put it in parentheses. And the reason that you need to do it, I can kind of give you an example. If you don't put it in parentheses, you don't know if the 1-methyl is talking about hexyl or talking about cyclooctane. So for example, you can imagine this situation where you have a hexyl group and a methyl group both on the ring itself. So this would be 1-hexyl 3-methyl cyclooctane. Okay, so 1-hexyl 3-methyl cyclooctane, because both of these are substituents on the cyclooctane. That's in contrast to the case we just looked at, where the methyl is a substituent on the hexyl, so you have to put that whole the whole substituent in parentheses. All right, let's take a look at the next example. So we have a 5-carbon ring, and we have a 1, 2, 3, 4, 5, 6, 7, 8 carbon chain. So 8 is greater than 5, so that means that the parent is going to be the linear chain, the octane, and the ring is going to be a substituent on that octane chain, because 5 carbons less than 8. So you're going to have a cyclopentyl substituent at carbon 2. So you're going to have 2 cyclopentyl, and then you're going to have a methyl at carbon 3. And we do want to alphabetize these, so M versus C. So this will be 2-cyclopentyl, 3-methyl octane. Squeeze that in there. So we can name cyclic alkanes, branched alkanes, straight-chained alkanes, haloalkanes, nitroalkanes, and the last type of molecule we're going to learn how to name is today, anyways, is our ethers. So quickly draw the generic structure of an ether. Yes, it is ROR, where R is just a generic alkyl group. Okay, so we have ROR. Awesome. So we're going to name ethers as alkoxyalkanes. So what we're going to have an alkane. So one of these R's we're going to name as an alkane. And then the other R, we're going to name it with the oxygen as an alkoxy. So alkoxy means alkyl group with an oxygen on it, substituent. So the one that's named as an alkane, that's going to be the longer chain. And the alkoxy, that's going to involve the shorter chain of carbons. So let's get started on that. So go ahead and see if you can draw the skeletal structures for these ethers. So ethoxypentane and methoxymethane. Okay, ethoxy. So that's 2 carbons and an oxygen. 2 carbons and an oxygen. Right? And then pentane. So that would be a 5-carbon chain off of that. So 1, 2, 3, 4, 5. Put in the numbers just to be sure that we did it correctly. Awesome. So ethoxypentane. All right, methoxymethane. Well, methoxy, that would be a CH3 and an O, methoxy. Methane, that's a 1-carbon chain. Okay, 1 carbon, 1 carbon, methoxymethane. We had no choice, right? The chains were the same length, so one of them was the methoxy, the other was the methane. All right, last example, hexoxybutane is the incorrect name for an ether. Okay, hexoxy. Hexoxy, that would mean 6 carbons and an oxygen. So let's see if I think we're maybe missing one, but let's see. And that would be pent. One more. No, that's 6. Hexoxy. Butane, 1, 2, 3, 4. Well, why isn't that the right name? Right, the alkoxy part, that is the shorter chain. And the alkane part, that is the longer chain. So in fact, the 6-carbon chain, that should have been hexane, and this should be butoxy. But for 4 and oxy for oxygen. So that should be butoxyhexane. All right, what can we name now? Let's summarize and be done. We can name the not functional group, right? We can name straight chain alkanes. No functional group. We can name branched alkanes. We can name cycloalkanes. All right, with some group on it. So cycloalkanes. We can name alkyl halides. We can name ethers. And anything not listed here that we can name? Yes, we can name nitroalkanes. So the only way to make sure you have this down is to go practice, 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 practice.